Guys, I hope you're good. I'm also fine. So today we'll be discussing integration by parts. So I'm sure you have noticed that on the previous videos, all of the integration rules that we're discussing, they were corresponding to one of the differentiation rules, because of we know that in integration we're going back to what was differentiated before. You understand? So this one, integration by parts, it's more like basically I'm gonna say it corresponds to product rule. You understand? So integration by parts correspond to product rule. So it's more like we're given an answer of product rule whereby product rule was applied, and then Tina, we're taking that answer to go back to what how the question was before. You understand? Or how the expression or was before. So that's what we're trying to find out through integration by parts. So this integration by parts is applicable to different types of situations, I can say. So let's start with this first one. The first one is whereby we have a product of two functions. For example, here we've got x and sine of x. So these two functions, if you were to make one f of x, then the other one can't be f prime of x. Understand? For example, if you were to make x f of x, then this can't be f prime of x, as well as if you were to make this f of x, this can't be f prime of x. So the two examples are examples whereby we apply integration by parts. So I'll show you how it's done just after showing you different situations whereby integration by parts is applicable. Sometimes you'll just have integration of just one function. For example, inverse trigonometric function, it will just be an integral of only that inverse trigonometric function. So you need to know that in situations like this, we apply integration by parts. So of course I'm going to show you how it's done. So for now, I'm just letting you know that if you come across this type of situation, then we're going to apply integration by parts. Of course I'm going to do examples, so stay tuned. And then this integration by parts is also applicable in when we are integrating our logarithmic functions. So you see, sometimes it could be alone, these logarithmic functions, like this one, the inverse trigonometric function was alone there. So as well as when the logarithmic function is alone, we apply logarithmic functions. You understand? We apply integration by parts when we're integrating logarithmic functions, even if it's with another functions. For example, here it's with this algebraic function x, then we still apply integration by parts. So last one, of course, being whereby we have positive odd powers of secant and cosecant. For example, integral of secant cube of x dx, as well as cosec to the power 5 of x dx. So these two examples are also examples of when we apply integration by parts. So I'm gonna show you all of these examples. I'm gonna show you how it's done for all of those examples, and then after that we do some activity, then that's it. So now let me show you how to work this integration by parts, because there is a way of how to solve it. So we use the thing called Liat, this order called Liat. So this order helps us to know that this function, since always in integration by parts, we're integrating, it's an integration of two functions that are multiplying each other. So out of these two functions, you have to have one of the functions listed there. It's either there is one logarithmic function, one inverse function, algebraic functions, trigonometric function, as well as exponential function. You have to have two of these functions here that are listed here. You understand? So now let me just show you examples of logarithmic functions just to make sure that we are on the right track. I don't want to write something there and then you end up not understanding what I'm doing. So Okay, in logarithmic functions, let me just do examples of logarithmic functions. It's your ln of x and then log of x, blah blah blah. So those are your logarithmic functions. And then as well for inverse trigonometric functions, this is where we have inverse sine of x, inverse tan of x, and blah blah blah. Okay, and then algebraic functions, this is your x to the power of 0. That means it's a constant. For example, in most cases it's gonna be 1. So if we have another function as 1, then we need to know that it's part of the algebraic functions. And then it could be 1 or anything, 2, 3 constants. We know you have to know that constant has an x to the power 0. Also we could have x, maybe another one, x plus 3. These are algebraic functions. X squared plus 4, 4x, blah 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 blah. These are algebraic functions, you understand? And then trigonometric functions, these are your sine of x, cos of x, cot of x, blah 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 blah. You understand? So those are the functions that you'll be coming across. So I'm just to make sure that everyone is in the right track when I'm doing things. I don't want you to be surprised that this is a trigonometric function. I want us to be on the right track. All right, and then exponential functions, these are your 2 to the power x, 3 to the power x, plus 1 maybe, and then e to the power x, blah 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 blah. So those are your exponential functions. Okay, now that you know different types of functions, and I told you that we are going to use this order called linearity. You understand? So according to this order, a function that comes first, so we start from the top there. So a function that comes first according to this linearity order, we differentiate it. And then a function that comes last, mean for my exponential function, we integrate it, because we have to differentiate and integrate through the process of solving this integration by parts. So I repeat, according to the linearity order, the function that comes first, we differentiate it. The function that comes last, we integrate it. So you'll see, of course, you'll see. Don't worry. It's gonna be clear. It's a very easy one, this one. So let me just use this example to explain what I was talking about, because I need to really explain what I was talking about. Okay, so we have these two functions. So first thing first, when you get your equation, when you get your question of integration by parts, you need to then identify the different types of functions that are there. You see here we've got an algebraic function and an exponential function. You understand? So out of the two functions that you have, one has to be differentiated and then one has to be integrated. Makes sense, right? So all right, so we've got an algebraic function and an exponential function. So I said, according to the linearity order, the function that comes first, we differentiate it, and the function that comes last, we integrate it. So since here we've got an algebraic function and an exponential function, that means the algebraic function, we must differentiate it, and the other exponential function, we must integrate it. All right, I hope that makes sense. So all right, now that you understand, or now that we are on the same page, let me do this. Okay, so this is what you do. Ne? You must write this. So anyway, also I'm sure maybe in classes you might have been taught UV, DV, what. I don't use those UV, what. I don't use them. I use another method, but it's basically the same thing. The difference is that I don't write UV, what. I just write the answer. So you'll see. I feel like mine is just easy, because you don't have to cram what is U, what is V, what is the V. You just write the answer. So but it's more or less the same thing. So don't worry, it's still the same thing. I'm not going to teach you nonsense. All right, so this is how I do it. So we've got two functions. All right, let me create enough space. All right, let me create, or maybe let me do it on a side. Yeah, let me do it on the side. Ish. Okay, we've got two functions. So the function that you identified as the function that you're going to differentiate, you write it here. You write it here. And then the function that you said you are going to integrate, you write it here. Makes sense, right? So from here to here, we differentiate. Differentiate. Makes sense, right? It has to. It has to. And then here, from here to here, we integrate. Integrate. All right. So that means from here to here, I'm going to differentiate x. So my x here, when I differentiate x, is going to be 1. And then when I integrate my e to the power x, it's still going to remain as e to the power of x. Now comes the part of writing the answer then. Then now you come and say, integration of x e to the power x dx is equivalent to, so the first thing here that you do is that you say, for you to get the first part of the answer, you say this second quadrant multiplied by the third quadrant. You understand what I did there? Minus, okay, so it's going to be that second multiplied by the third quadrant. So it's going to be x multiplied by e to the power x. Minus, this minus sign that I've just written comes from the rule. You understand? Comes from the rule of integration by parts. And then you say minus the integral of what? Of, what is this? Of your third multiplied by the first quadrant, just like that. So that means here I'm going to say, minus the integral of just e to the power x dx. And then you're done. Then you continue with your integral to integrate the other one until you have plus c. So it's going to be e to the power x minus, when we integrate e to the power x, it remains as e to the power x, then plus c. Then you're done. Ta-da! You have your answer. So that's how basically I do it. So we'll be working with my method for the sake of this video, because I even forgot how to do that one of UV/dV. It's been a while. I learned it, and then after a month I discovered that no, this thing could be done in this way, and then I let go of that method of UV/dV because I don't want to cram a lot of things of UV what. So yeah, so that's basically it. So now what are we gonna do? Let's just quickly do another example, and then I explain again what is happening. So now now that you've got an idea of what's happening, so I'm gonna just rewrite write the Leerte thing again, yeah, Leerte, because it's the one that we always use. So now let's identify the two functions that we have here. So we have an algebraic function and what? And trigonometric function. So that means we've got an algebraic function and a trigonometric function. According to the Leerte, the function that comes first, we differentiate, in the function that comes last, we integrate it. So here we're dealing with this guy and also this guy of the trigonometric function. So algebraic function comes first. So when we draw our thing here, our cross, it's gonna be like this. So you're gonna write your algebraic function here because it's the one that comes first, and then the trig function that comes last, you're gonna write it here. Okay, so now we know that when we move to here to there, we differentiate. When we move to here to there, we integrate. So now let's differentiate x squared. How much is it gonna be? It's just gonna be 2x, right? Now let's integrate cos of x is just gonna be sine of x, right? I hope you're not having a problem with integrating the trigonometric functions. Otherwise, if you do, feel free to go back to my previous videos. I've shown you how to integrate trigonometric functions. So please make sure that you understand, because now it's more like basics now, because we are dealing with integration by parts, so we can't be having problems with that. All right, so now now we can then write our answer. So why am I showing you this example? So this example, it's there because of I want to show you that sometimes you will be supposed to do integration by parts 2 times. It can even be 3. Okay, sometimes you can repeat integration by parts. You'll have to do it 2 times, you understand? So this is one of the examples whereby we apply integration by parts 2 times. So that's why I'm showing you this example, so that you can know that there are questions whereby you integrate by parts 2 times. Make sense? So stay tuned and let's see how it's gonna be done. All right, so here we've got integral of x squared cos of x dx, which is going to be equivalent to, I said from here, we say second quadrant multiplied by the third quadrant. So it's just going to be x squared. It's just going to be x squared multiplied by sine of x. Minus, this minus sign comes from the formula. So don't question that minus and say, oh, where is this coming from now? So please. All right. So now, and then for this other part, we say first multiply by the third quadrant. So this is going to be 2x multiplied by sine of x dx. And then you're done. Then from here, now we're supposed to integrate this part again, right? We realize that now we still have integration by parts again, because we've got 2 different functions that are multiplying together, multiplying each other, and we cannot be able to make one f prime of x and the other one to be f prime of x. Understand? We cannot make one f of x and the other one be f prime of x. So that means this one, we still have to go with integration by parts again. So we go back to the cross again. You draw the cross now. Again, you draw the cross. It becomes like this. And then from here, you've got what? According to Leah, tell him just rewrite Leah again, but Leah. So here we've got algebraic function, which is 2x. So we've got this. And the trigonometric function. So according to Liat, the function that comes first, we differentiate it. So that means I'm going to write my 2x here. And then the function that comes last, we write it here. So it's going to be my trigonometric function of sine x. I'm going to write it there. You understand? So from here to here, we differentiate. From here to here, we integrate. So now let's do that. When we differentiate 2x, it becomes what? Only 2. When we integrate sine x, what do we get? We get negative cos of x, right? So this one, it becomes negative cos of x. And then that's it. Then from here, we can then continue with our solution, right? So integration of x squared cos of x dx is equivalent to x squared sine of x minus, and then now, so this minus that I've written here, it's this one, you understand? So this one here. So now we are writing that part of integration by parts. Remember, I'm writing this. I wrote this so that I could answer this integration here. So you understand? So now I'm answering it. For this part, I know that second quadrant should multiply this third quadrant. So it's going to be negative 2x cos of x, right? Cos of x. Minus, this minus is coming from where? From the formula of integration by parts. Remember, we're integrating now this part by parts. So this is going to be minus the integral of what? Of this first quadrant multiplied by the third quadrant. So this is going to be minus 2 cos of x, right? Cos of x dx. Then I close. Okay, look, to save time, so this negative, I'm gonna take it out and then I'm gonna multiply with this one, and then I'm gonna have positive. It's better to work with positive signs sometimes. When you have a lot of negatives, it's easier to make mistakes. So I'm not here to make mistakes. I want to write things that I make sure. So this is going to be x squared cos of x dx, which is equivalent to, now I continue, I copy this is still x squared sine of x. So now I multiply, this multiplies this, what do I get? I get or maybe before I multiply I can leave it like that. Yeah, let me just leave it like that, ne? And integrate first. I'll multiply later so that I do one step at a time. So this is still gonna be minus 2x cos of x. So now let's integrate this one. So of course the 2, we can also take this 2 out. Let's take the 2 outside the integral. So it's going to be 2 integral of cos of x. So when we integrate cos of x, what do we get? We get positive sine of x, right? So it's going to be plus 2 sine of x. And then what? Then yeah, that's it. And then we close. We write our plus c. We're done. Of course, we need to then multiply this bracket out. So I'm still gonna copy the very same thing. It's gonna be x squared cos of x dx, which is equivalent to x squared sine of x. Minus times minus, that's going to be plus 2x cos of x minus 2 sine of x, and then plus c. Then ta-da, you're done. You got your answer. So that's how it's supposed to be done for integration by parts. So that's basically integration by parts. So yeah, that's how you're supposed to do it as well. All right, now let's quickly check another question, of course. So we've got this guy here. We've got you, my guy. We've got this guy. So, okay, I'm quite sure you have not. Have you seen that when I was answering my question, I was copying the question and say equals to. Like, you see, this question was integral of that. I was copying that question and say equals to, you understand? So this is how we are supposed to write. It's important mostly in the question that I'm about to do, because of this is one of the questions whereby you will never stop integrating. You understand? Like, the integration by parts keeps on repeating and repeating and repeating until it's an infinity loop. You can integrate until you die. So for you to at least stop integrating before you die, then you need to copy the question every time. You copy your integral question there, you say equals to. At least that way you're going to stop integration, because you're going to realize that now the thing that is repeating is available on my left hand side. So I can just take it to my left hand side and then I stop integrating. So that's what we're going to do here. So stay tuned and see how we're going to do it. So all right. So LIATA is still applicable. So let me just write LIATA. This is the most important thing. So LIATA. All right. So now let's identify the two different functions that we have here. We've got an exponential function and a trigonometric function. That means we have a trigonometric function and an exponential function. According to the LIATA order, a function that comes first, we differentiate it. A function that comes last, we integrate it. You understand? So that means when we write our cross here, what are we going to write? We're going to write the function that comes first, which is the trigonometric function. So we're going to write sine x. And then the exponential function, we're going to write it here. All right. And then we know that when we move from where? From here to here, we will do what? We differentiate. So when we differentiate sine x, what do we get? We get cos of x. And then from here to here, what do? We integrate. So e to the power x remains as e to the power of x. Then we're done. Then now we can write our answer. Of course, we need to always copy our equation. So here it's still gonna be e to the power of x, e to the power of x multiplied by sine of x dx, which is equivalent to what? Which is equivalent to second quadrant multiplied by the third quadrant. So this is just gonna be e to the power x multiplied by sine of x minus integral of what? Minus the integral of e to the power x multiplied by what? Cos of x. So you know that Ankara have said that for this first part, we say second multiplied by third, and then for this other part, we say minus the integral of this multiplied by that, which is the first quadrant multiplied by the third quadrant. You understand? So it's gonna be like this. So then now we just need to integrate. So now that we're supposed to integrate this part again, we realize that, nah, man, we still have an exponential function and a trigonometric function, meaning that we're still supposed to apply integration by parts again. So now we go again. We say, okay, it's fine. Okay, we're still gonna use the Linear. We've got a trigonometric function and an exponential function. So that trigonometric function is the one that we're going to differentiate because it comes first. And then the exponential function, of course, we're gonna integrate it. Then we write our cross. We write our cross here. Ta-da! Here's our cross. And then we write our cos of x here. Cos is the function that comes first, and then we write our exponential function here. Then, like always, from here to here, we differentiate. So when we differentiate cos x, what do we get? We get what? Negative sine of x. Okay, now from here to here, we integrate. So to integrate e to the power x, it remains as e to the power of x. It doesn't change. It doesn't change. It does not change. So that's it. It does not change. All right. Now that we have this, then that means we can work this part. All right. We do it now. Then we say e to the power x multiplied by, we copy the same thing again. It's the procedure. It's supposed to be done this way. So you shouldn't feel pain when doing it. It's how it's supposed to be done. Everyone everyone does it like that. So sine of x. Now this minus that I've written here, it's this one. I just copied these two parts, and then now I copied the minus sign as well. So now I want to apply integration by parts for that other integral. So to apply integration by parts, if you are using this method, of course, you need to say this second quadrant multiplied by the third quadrant. So it's going to be e to the power x, e to the power x multiplied by what? By cos of x minus, so this minus that I've written comes from the formula of integration by parts. All right, minus what? Minus the integral of what? Of third quadrant multiplied by the first quadrant. So that one is going to be minus e to the power x multiplied by what? Multiplied by sine of x. So sine of x, then your dx, of course, then you close the bracket. So what I'm going to do now is just to take this negative sign outside the integral, and then it's going to multiply with this one, of course, and then it's going to form a positive sign. So I'm going to remove it there, and then blah, ta-da, I have my positive side. Makes sense, right? Yeah, it is true. What else should it do? It must make some sense. So from here, now I need to multiply by the negative sign so that I have these parts. Okay, so I'm gonna copy the same thing again. The procedure is like that, guys. So it shouldn't be a problem to copy this because you're just copying, you're not doing anything. So e to the power x sine of x minus e to the power of x cos of x minus again. So this negative multiplied this, it became negative. This negative again multiplies this. It becomes another negative of integral of e to the power of x sine of x dx. So what happened, guys? So look, initially, okay, so now, okay, maybe before I ruin the moment, look at it. Now again, integration by parts is coming back again. So that means we should integrate by parts again. Technically, it means so. You understand? It means we are supposed to integrate by parts again until we don't have integration by parts. But unfortunately for this one, already tells you that nah. According to off. So look at it. Initially on our question, we were given that we should find the integral of e to the power x multiplied by sine of x dx. You understand? So when you check here, again, now I'm supposed to find integration of e to the power of x sine x. It popped out when I was busy solving this very same question. What does it mean? It means that, again, if I were to solve this integration by parts again, it means I'm going to go through the very same steps again until I reach here and then again another one pops in again, and then I integrate again through the very same steps until I reach again. So that's why I'm saying this is one of the questions that is going to be an infinite loop. You'll integrate until you die. So before you die, you must at least have solved this question to the last. So before that, at least let's see how this one is supposed to be done. So when you check on your left hand side, remember I said the left hand side is very important. It's very important also for this question, more especially for this question, I mean. So look at it. On our left hand side, we are solving integration of e to the power of x multiplied by sine of x dx, which is the very same thing that we have on our right hand side as integral of e to the power x multiplied by sine of x dx. So what does it mean? It means that we're supposed to take this guy and bring him there to the left hand side so that they can be together with his or her friends. I don't know, is it a he or she, this one? But together, they should be together because they are the same, right? Also, this one is negative, so when we take it to the other side, it's gonna just be 2 integral of that, right? So I'm gonna take it to the other side. It's gonna change the sign. Since it's negative here, when it goes to the other side, it's gonna change the sign. So it's gonna end up becoming 2 integral of what? 2 integral of e to the power of x sine of x dx is going to be equivalent to whatever that's left here, which is e to the power of x sine of x minus e to the power of x cos of x. You see, these are the things that are only left here on this side. All right, but then on my question, I was not solving for 2 integral of this, so I must get rid of this 2 by dividing by 2 on both sides. So to get rid of the 2, I'm going to divide on both sides, and then I'm going to be left with e to the power of x sine of x dx, which is going to be equivalent to 1 over 2. As well as here I can see I've got a common factor of e to the power x, only I can just as well as take e to the power x as my common factor, and then I'll only be left with sine of x minus cos of x. Then I close the bracket, I say plus c. Ta-da! I have my final answer. So that's it. So that's why I say that it's very important to always write the left hand side there. It's important for cases like this. Makes sense, right? So that's how it's supposed to be done. Here I divided by 2 on both sides. So when you divide by 2, I'm gonna have 1 over 2. So this is 1 over 2 here. It comes from when I divided by 2 on both sides, and then I took out e to the power x as a common factor. It came here, and then I was left with that. So that's it. Let's check another example. Okay, like I've said prior, before I showed you how integration by parts is solved, I had already told you that in integration by parts, what I said that, I showed you application of integration by parts. I showed you different situation whereby integration by parts is applicable. So this was one of the situations whereby integration by parts is applicable. So it's very important as well. Let's quickly see how it can be done. You understand? So let's see. Stay tuned. Okay. Okay, we're still gonna use Liate. The Liate, it's very, very important every time whenever you are using integration by parts. So we've got two functions here. What is the other function? The other function is 1. So we've got 1 here. You understand? We have 1 there. So that's the other function. Remember, I said 1 has x to the power 0 and it's part of the algebraic functions. You understand? It's part of the algebraic function. So that means we've got an algebraic function, we've got a logarithmic function, of course, and an algebraic function here. So according to the Leiter order, the function that comes first, we differentiate it, and the function that comes last, we integrate it. That means now when we come to write our cross here, we're going to write our cross, of course. Ta-da! There is our cross. So we've got two different functions. The first one being ln. Okay, so this ln squared. So I'm going to write it like this, ln of x squared. And then I also have my 1 here. All right, so I wrote my two different functions. You understand, right? So when we move from here to here, we differentiate. And when we move from here to here, we integrate. So the very same explanation still applies. So we're going to differentiate this. This is going to be 2 ln of x multiplied by, we're going to use chain rule, of course, so multiply by 1 over x, multiplied by 1 over x for us to get that part. Then we integrate 1, we have to get x. Makes sense, right? So now that we have those parts, what else do we need? What else do we need? So now we then need to just write our integral, like answer our question, try to answer our question. So when we try to answer our question, we're gonna copy the very same thing. So it's going to be ln squared of x dx, which is equivalent to second quadrant multiplied by the third. So this is going to be x multiplied by ln squared of x minus the integral of what? Of what is this? Third quadrant multiplied by the second quadrant. So when we multiply that, you realize that this x will cancel out 1 over x. Makes sense, right? So we'll only be left with 2 ln of x dx, right? Okay. Now that we have this, we realize that okay, again, we've got two different functions, which is this algebraic function, because I said any constant, it has x to the power 0. So anything of x it's part of the algebraic function family, you understand? So that means for this case as well, we're supposed to use what? Integration by parts, because of we have an algebraic function together with this logarithmic function. So that means we're still going to use the Leiter order, and the first one, it's still the logarithmic function, and the algebra still comes last. That means when we draw our cross now, when it comes to drawing our cross, we're going to write what? The logarithmic function here, ln of x, and then we write our 2 here. Then from here to here, we do the same thing. We what? We differentiate. So that's going to be 1 of x. 1 over x, I mean. Then from here to here, we integrate. That's just going to be 2x. I hope you're not having a problem with integrating and differentiating this. We have already passed here. So yeah, you should be cruising now. You are supposed to be cruising. Okay. Now that we have this cross, that means we can just answer the integral part of this one. You understand? So let's copy the same thing, because it should always be with us in case we have a repeated integration by parts. So it's very important, this left hand side, to be always copied. You understand? So this is going to be ln squared of x minus what? So this minus that I've written here is this one. You understand? So I've just copied it. Now I need to apply integration by parts. So I'm going to open my bracket and then apply integration by parts again for this one. So this is going to be this part, second quadrant multiplied by third. So that's just going to be 2x multiplied by ln of x minus integral of what? Minus integral of, so 2x when it multiplies this one, what's going to happen? 2x when it multiplies 1 over x, the x and x will cancel out. At the end of the day, we'll only be left with 2. dx. I hope that makes sense, guys. I hope you are not having a problem with that. If you multiply 2x with 1 over x, the x and x are gonna do the thing of chopping each other. So once they've chopped each other, we'll only be left with the 2. Hope that makes sense. It should. All right, now we just need to do what? Okay, maybe I can start by integrating that part before I multiply by the negative sign outside. So I'm gonna say I'm copying now. Ln squared of x dx is going to be equivalent to x multiplied by ln squared of x minus 2x ln of x. Oh, it's more like I didn't want to multiply already, so I'm not multiplying already. Let's leave this one inside and then apply the integral first. So let's apply the integral. When we apply the integral of 2 there, the x, it's supposed to be just 2x, right? It's supposed to just give us 2x, and then I close. I have my what? My plus c. Because immediately when you no longer have the integral of what was on your left hand side, you should just write your plus c, you know. So then from here, I copy the very same thing again. It's going to be ln squared of x. The x is going to be equivalent to x multiplied by ln squared. So ln squared of what? Of x minus 2x ln of x. So now I'm multiplying by this negative. So this bracket here is multiplied by this negative. So that's why I got the negative. Negative by negative again becomes positive 2x, and then what? Plus c. Plus c. Then tada, you have your final answer. So that's just it. That's how it's supposed to be done. Okay. All right, we've got another one here. We've got another last one before we could go to what is this? Before we could solve the activities. So I have to also remind or let you know that the same thing is going to apply. Let's take you've got the integral, and for example, let's take you've got the integral of tan inverse of x dx. Yeah, so you're still gonna use Liat, and then the other function has to be 1, the 1 here, you understand? So that means you will be having what? Inverse function and an algebraic function. So when you draw your cross, you're gonna have tan inverse of x here, because inverses comes first before algebraic, and then you write your 1 here, and then you integrate, you differentiate and also integrate, then you'll be able to solve it. So I just want to let you know that, yeah, for inverses of tan, for cases of tan inverse as well, we're going to apply the very same procedure. So it shouldn't chop you. It shouldn't chop you. So it's just a minor thing. So yeah, I'm sure you have noted it down. We might meet it in one of the activities that we're going to do here. So yeah, that's it. Okay, now let's check this. Let's check this one. So now we've got integral of what? Integral of sec cube of x. I've already told you that whenever we have got positive exponents, positive odd powers of what? Of secant and cosecant, we should use what? Integration by parts. So now that you know that we use integration by parts, that means you are aware that, okay, for this one as well, we're going to apply integration by parts. So let's just do it. Remember, Liat, it's always applicable. So let me write it here on the side. Liat. So now let's, okay, so this one, it's special, ne? It's special in this way. We don't really use Liat, but it's what? It's part of the integration by parts. So look at it. You need to first split it out. Okay, that means I'm gonna let you know about something. So stay tuned. Stay tuned. Maths is very, very, very broad. It's very, very broad. So here we've got sec of x. So you split it here whenever you have this odd thing. You split the sec, one of the sec out, and then you take then you'll be left with sec squared of x and then dx here. Make sense? So basically in integration by parts, other people will say that there is an explanation of integration by parts that goes as follows. We always integrate the part that looks easier. So that's how they say. They don't really like, they do follow Liate when it's necessary, but in most cases they use explanation that says that we integrate the part that is easier to integrate. So I feel like that explanation is tough to me, hence I always try to solve these questions using Liate, but for this one it's gonna be an issue because of we've got the same trigonometric functions, you understand? We've got a trigonometric function and a trigonometric function. So what are we gonna do? So we have to go with that explanation of saying that sometimes we have to integrate the part that is easier to integrate, or as well as differentiate the part that is easier to differentiate. So that's how other people work with integration by parts. Hence, myself, I always fight for each and every question. If it's possible, I try to use Liate. But anyway, there are two explanations. I have to admit that. So let me just also, for this case, I'm gonna go with that other explanation because I feel like that other one is for experts. If that one is wrong, it's chopped me, but I don't know. Yeah, but yeah, that one is for people that are too good or advanced when it comes to this integration by parts. So anyway, let's go with their method, because for this case we can't avoid it. All right. Now that we have this guy here, we have to use the cross again. So according to that explanation of, if you've got two different functions, you have to make sure you integrate the one that is easier to integrate, you understand? So between sec and sec squared, they say sec squared, it's the one that is easier to integrate because of, we know that there was something that was differentiated for us to get sec squared, you understand? So that means here I'm gonna write my sec squared of x, and then here I'm gonna write my sec of x, and then the very same explanation from here applies. When we move from here to here, we differentiate. That means when we differentiate sec x, how much is it going to be? Sec x tan x. So that means here we're going to have my sec x tan of x. Sec of x tan of x. And then that's it. We're done. And then sec squared, from here to here, we integrate. When we integrate sec squared is coming from what? From tan of x. So it's coming from tan of x, and then ta-da, we've got our cross there. So when we have our cross, we know that we just have to say we copy the very same question, of course. So we're going to copy sec cube. So I'm gonna copy my sec cube here. Integral of sec cube of x, sec cube of x dx. Okay. And then I say what? Sec cube of x. After that, I say second quadrant multiplied by third quadrant. So this is going to be sec of x tan of x. Sec of x tan of x. Sec of x tan of x, right? Ish, I hope. Let me just try to make my handwriting nice. Sec of x tan of x. And then minus what? Minus the integral of first multiplied by third quadrant. First multiplied by third quadrant. So I'll end up getting minus the integral of what? Of sec of x multiplied by tan squared of x dx. So what is happening here is that I multiplied my third and first quadrant, then I got this part. So now I realized that it won't be easy for me to integrate this. So I need to change the tan squared into what? Into its equivalence when it comes to square identity. So tan squared is equivalent to sec squared minus 1. Sec squared of x minus 1. So I'm still going to copy the very same thing just to substitute that one. And then here I'm still going to copy the very same thing. So this is going to be sec cube of x, which equals to sec of x tan of x minus the integral of what? Minus the integral of sec of x. I said I'm only changing tan squared to sec squared. So this is going to be sec squared of x. So this is going to be sec squared of x minus 1. Then I have my dx here. Of course, I'm going to multiply out here. So I'm going to have sec cube of x minus sec of x, right? Alright, so that's what I'm going to do. So again, I'm going to copy this thing out. So I'm going to copy sec cube of x dx, which is going to be equivalent to sec of x multiplied by tan of x minus the integral of what? Minus the integral. So I'm going to multiply out and then at the same time split. So when you split, because I'm going to get two terms, when I multiply this I'll get a term, and then when I multiply again I'll get another term. So I'll end up having two terms, sec cube minus sec dx. So I'm going to multiply and then have two integrals again. So I'm going to say sec cube of x. So when you multiply sec x with sec squared, you get sec cube. And then this one is going to be minus times minus sec. So it's going to be plus sec. I hope that makes sense. So this is going to be this dx plus sec of x dx. So what happened? I multiplied this negative by that negative, multiplied by sec, so I multiplied by the integral as well, and then we got positive. I hope that makes sense. So, okay, like I've told you, it's very important to always write this left hand side, because it's gonna help you in cases like this. Because now you are coming across another sec cube. What does it tell you? It's telling you that, my guy, take me to the other side. Take me to the other side. You can't integrate me again. So that's what it's telling you. So what you need to do is just to take it to the other side, and then we will end up having two integral of what? Of sec cube of x dx, which is going to be equivalent to whatever that you have here on this other side, which is going to be sec of x. So sec of x tan of x, and then we integrate positive sec of x. It's there on our integration formulas. So if you have already memorized your integration formulas, then it's going to be easy for you to integrate it. Whenever we integrate sec, it's just ln. So this is going to be plus ln of what? Ln of sec of x plus tan of x plus tan of x, and then you close. Then you're almost done. Then now you're not done, because of you need to divide by 2 on both sides, so that you can solve your integral of sec cube. So when we divide by 2 on both sides, we'll end up getting that the integral of sec cube of x dx is equivalent to what? To 1, is going to be equivalent to 1 over 2 multiplied by whatever that you have here on this other side. So this is going to be 1 over 2 multiplied by whatever that we have here, sec of x tan of x plus ln of sec of x plus tan of x. Then plus c. Ta-da! You're done with that integral there. Makes sense? So yeah, that's how basically you are supposed to do it. So I hope you got the concept, and now it's time for the activity now. So now we're done with the basics. We've covered all the situations whereby integration by parts is applicable. You understand? So stay tuned. Stay tuned. Stay tuned. Stay tuned. All right, stay tuned. Now that you are tuned, let's do these questions there. It's good that you are tuned. You should be tuned. You should be tuned. You should be tuned. Otherwise, if you're not tuned, then there's gonna be big matata. And we don't want big matata. We want to solve these problems. All right. Under activity 9, we should integrate the following questions. So we've got different questions, of course. So please, now it's your time to also be writing something. Also be attempting this question as we move forward, because of you have been copying for quite a long time now. It's now time to put in some work as well. So please, guys, take out a piece of paper there and a calculator if necessary. And then we're gonna be solving the following activity together. So what you need to do is just to pause the video before you see the memo, and then you quickly do it on your own, and then later you will resume to see how I've done it. That way at least you will be learning, okay, I made a mistake there, you see, then it will be making some sense there. You'll be doing some and then that way it's a way of learning. All right, let's start then. We've got the integral of x squared multiplied by e to the power of negative x. When we see this question, you can see that, okay, you've got two different functions, and these two functions, you cannot be able to make one f of x and the other one becomes f prime of x. So what are you gonna do? You need to use integration by parts. So this is where the LIATE comes in now. It comes into your rescue. So let's go. So what do we do now? We have, let me write our LIATE. LIATE. So sometimes you don't really have to write this LIATE if you once you are used to solving, you don't really need to write it down, you understand? Because it's not for marks, it's just there to help you to know which function are you supposed to differentiate and which function are you supposed to integrate. So since we have two different functions, our algebraic function, we've got an algebraic function and an exponential function. So what are we supposed to do? We're supposed to differentiate the algebraic function that we have and integrate the exponential function that we have. So I'm going to write across, draw my cross. Is it a draw or write? Did I write this or did I draw this? You guys who did English home language, can you please tell me, guys, am I writing this cross or drawing it? When I do this, is it writing it or drawing it? Yeah, whatever. But I feel like I did one of the two. It's either I drew it or I wrote it. Yeah. Okay, anyway, let's quickly go back to maths. So we identified that we have an algebraic function and an exponential function. So algebraic function, since it comes first, then we need to differentiate it. The thing that comes last, we integrate it. So we're going to differentiate our algebraic function, which is x squared. So we have x squared here. We're going to differentiate this x squared and it's going to become 2x. And then we've got e to the power negative x. We're going to integrate it. It's going to become negative e to the power negative x. If you're having a problem with integrating this thing, then definitely you need to go back to my videos and then check how I explain integrating these things, because we have done integration of exponential functions. So by now you should be a master of integration of exponential function. You shouldn't face some problems. So yeah, this is how it's going to be. All right, now after having the cross, we know that we do the very same procedure. So here we're going to copy x squared e to the power of negative x. You copy it and then you say dx, you say equals to, you say second quadrant multiplied by the third. So this is going to be negative what? Negative e to the power of negative x, negative e to the power of negative x, or negative x squared e to the power x. It's fine. Like I like it's beautiful like that when I start with x squared. Okay, so e to the power of negative x minus, so the minus that I wrote there comes from integration by parts rule. Then minus what? Minus first multiplied by third. So this is going to be minus 2x multiplied by e to the power of negative x dx. And then we realize that again we've got integration by parts, because we cannot be able to make 2x the f of x and then the other one become f prime of x. Even if we were to make this f of x, this can't be f prime of x. That tells us that we need to use integration by parts, because this thing is a product of the two things. All right, then that means we'll go back to the to our cross. So I draw my cross there, and then I write. Another thing, let's take this negative sign outside. I don't want to be disturbed by negative signs, okay? So let's take this negative sign outside the integral. So I'm going to take it out, and then it's going to cause this one to become a positive sign outside there. Make sense? So let's again identify the two functions that we're dealing with. We're dealing with an algebraic function and an exponential function. So according to the Leiter order, a function that comes first, we differentiate it, and a function that comes last, we integrate it. So this algebraic function of 2x, we're going to differentiate it. So this is going to be 2x, yeah? And then the exponential function, we're going to integrate it here. So now let's start. We differentiate 2x. How much is it going to be? It's just going to be a 2. We integrate e to the power x. It becomes negative e to the power negative x, and then tada, we have this. Now we just need to continue with our solution. So I'm going to copy the very same thing that I had, and then this is going to be integral of x squared e to the power negative x dx, which is equivalent to negative x squared e to the power negative x plus, so this plus sign that I wrote, I hope you can see that it's coming from where? It's coming from there up here, right? So I'm copying that one. So now I open my brackets. Now I want to apply my integration by parts here for this case. So it's going to be second quadrant multiplied by third. So this is going to be negative 2x e to the power of negative x, of course, minus the integral of what? Integral of first multiplied by third. So this is going to be negative 2 e to the power of negative x dx, yeah? And then I close. Then before I do anything, I would like to take out the 2 and the negative here outside the integral. So that negative will form a positive. So here I will have positive 2 integral of this. I work better with the positive signs, okay? It's easier, at least you minimize some mistakes there. Then from here, I'm going to copy the very same thing again. So this is going to be x squared e to the power of negative x dx, which is equivalent to what? To the very same thing here. I'm copying x squared e to the power of negative x. So before I multiply out, let me first integrate the thing that's inside there. So let me copy negative 2x e to the power of negative x. Then I integrate my guy here. When I integrate this guy, is going to be what? Negative e to the power of x. So multiplied by the 2 outside is going to be negative 2e to the power of negative x. Then I close. I write my plus c. Okay? Now that we are done, we need to just multiply by the positive sign throughout there. So I'll end up having integral of x squared e to the power of negative x. Dx is equivalent to negative x squared e to the power of negative x minus 2x e to the power of negative x minus 2 e to the power of negative x plus c. Ta-da! You have your final answer. So easy like that. So I hope you didn't face problems while solving it. Of course, one can say, I want to take this further. So you take out the common factor here of, so definitely this is going to be when you take out the common factor of negative e to the power of x. So if you were to take out that common factor, you will have the following answer. So this is going to be, you'll be left with x squared plus 2x plus 2 and then plus c. Ta-da! It's still the correct answer. So yeah, that's basically it. I hope you got the same answer as well. So that's it. That was it for that one. Let's quickly check if we can solve another one. Let's quickly see if we can solve another question. All right, so be getting these things, guys. They are easy, right? It's very easy. So we still have another integration by parts, because we can see even if you were to make this f of x, this can be f prime of x, or if you were to make this f of x, that can be f prime of x, meaning that we need to use integration by parts here, because we have the product of two different functions. So like always, liate, 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 liate. Okay, so now that I've written my liate, then we can begin. We identify the two functions that we're dealing with. We find that, okay, we're dealing with an algebraic function and a trigonometric function. So that means we're dealing with this guy and this guy. According to the liate order, the function that comes first, we integrate it, and the function that comes last, we integrate it. So we differentiate the function that comes first, and then the function that comes last, we integrate it. So, okay, thank you. Now that we've got our two functions, we know that we're differentiating x squared, and then we're integrating sine of x. So when we differentiate x squared, what do we get? We get 2x. When we integrate sine of x, what do we get? So when we integrate sine of x, we get negative cos of x. Didn't I do this problem? Let me just confirm, because it looks very, very familiar. I don't want to repeat problems that I did. X squared sine x, x squared sine x, x squared. Oh, it was x squared cos of x. So, shit. Sorry for the language. Sorry for the language. Okay, it's going to be the same procedure though. So, okay, let's quickly see how we're going to do this one. So, now that we have the cross, let's see. We're going to say going to copy first copy the equation. So this is going to be x squared sine of x, x squared sine of x. The x is going to be equivalent to what? X squared sine x dx is going to be equivalent to negative x squared cos of x. Where is this negative x squared cos x coming from? It's coming from, we say we always multiply by second multiply by third, right? Minus, the minus comes from the product rule formula, and then we copy first multiply by the third. So this is going to be negative 2x multiplied by cos of x dx, right? So now that we're here, we realize that we've got another integration by parts. What do? We integrate by parts again. Okay, I work better with positive sign, so I'm gonna take this negative sign outside, so it's gonna form a positive sign. So I take it out, it becomes positive. Makes sense, right? And then now I apply my by parts again, and then I go to the liate again. I identify that, okay, I have my algebraic function and my trigonometric function. According to the liate order, a function that comes first, we differentiate it, and the function that comes last, we integrate it. That means I'm going to write my 2x here, and then write my cos of x here. Make sense? And then so now I differentiate. So to differentiate 2x, it's going to become 2 when we differentiate 2x. When we integrate cos x, it's going to become sine of x. So cos of x comes from sine of x. And then now we apply our integration by parts, of course. So this is going to be x squared sine of x dx, which is going to be equivalent to negative x squared cos of x. Plus, so the plus sign that I wrote here comes from where? Comes from here, right? So now I'm about to apply my integration by parts. So I know that for me to apply integration by parts, I'm going to use this cross, of course. So this is going to be second multiplied by third. So that's going to be 2x multiplied by what? By sine x, right? So 2x multiplied by sine of x, right? And then minus, so it is going to be minus the integral of what? Minus the integral of 2 sine of x Vx, and then you close them. Then tada, now what is left? The thing that is left, now you can see that, okay, here I don't need to apply integration by parts again. I can just integrate this directly. So that's what we're going to do in order for us to be able to integrate this one. Okay, so I'm gonna copy the same thing, of course, again and again and again. So this is going to be x squared sine of x. Vx is going to be equivalent to negative x squared cos of x plus, so okay, this plus, okay, I haven't multiplied out. I want to integrate first there. So this is going to be 2x sine of x. So when we integrate this, so I've told you that you say what? Okay, the 2, we can take the 2 out. If the 2 is disturbing you, you can take the 2 out. So this is going to be minus 2. Minus 2, yeah? Yeah, minus 2. That way. Makes sense, right? I took the 2 outside the integral. I hope we don't have a problem. So to integrate sine x comes from where? Comes from negative cos of x. So that negative, so the answer for this integral, it's negative cos of x. And then it multiplies this other negative, then it becomes positive 2 cos of x. If you are having a problem with how to work out integral of trigonometric functions, kindly go back to my previous videos. You will definitely be reminded of how it's supposed to be done. Then I close here, I say plus c. Okay, now that I have my my bracket and I'm supposed to multiply, I realize that I have a positive signs which multiplies only the positive signs, meaning that since I'm using an x paired there, I can just eliminate this bracket, you understand? Because of it's positive by positive, it won't change anything, so I can just eliminate the bracket and then it's gonna be the same thing, then plus c. Tada, you have the answer there. So that's your answer. That's just your answer. Yeah, I hope you got to the same thing there as well. So let's quickly go to another question. We see what damage we can do to it. We see what damage we can do to this question. All right. Okay, we've got this type of question. Now we are supposed to integrate what is this? Cos of ln of x dx. Cos of ln of x dx. You understand? So this question could be done in 2 ways. You understand? Cos of I've told you that some people, when they explain integration by parts, they don't really follow the Leontief rule. But to me, I feel like it makes sense that way because of that explanation. That other explanation, they just say if something is not easily integrated, then we don't use it to integrate. Like that explanation, they deal with things being easy. So to me, I don't really know that which one it's easy between the two. Sometimes I struggle to identify that, okay, this one is easy, this one is not easy. So for this question, if I were to follow that explanation of saying now we follow the if we identify that this function is easy, then we differentiate it. Then if this other one it's easy as well, we integrate it. That explanation, I'm just taking chances on it. I don't really like get it. So I'm gonna force this one to be in a way that we can see that we can use Leontief. At the end of the day, we're gonna get to the same answer, as well as those are professionals that use that explanation of saying that this function is easy, the other one it's not easy. Understand? Okay, so let's quickly solve this one using let's force it to be able to be applicable in a way of using Leontief, of course. So what we're gonna do is that we are going to use U substitution. Why? Because of here, I can say we have we have two we have two different functions. I've told you that in most cases, when we have one function like this, we treat the other function as one, right? So look at this like this. If we were to apply Liat directly here, we're gonna have this problem. We've got an algebraic function and a trigonometric function, you understand? And according to the Liat order, a function that comes first, we differentiate it, and the function that comes last, we integrate it, you understand? So if we were to write cos of ln of x here, like if we were to write cos of ln of x directly here, we're going to have a problem of integrating it, you understand? As well as if we were to write 1 here, then we're going to have a problem because of when we differentiate 1 is going to be 0. To integrate this is going to be big matata. So I don't want this big matata. So I want us to first use U substitution to rewrite the given question in a nice way, you understand? Is that then we can be able to apply our integration by parts. Because Liat always works, you know. So when we apply U substitution here, we're going to let our U to be equivalent to ln of x. So U is going to be equivalent to ln of x. So this is going to be our U. Let your U to be equivalent to ln of x. And then that's it. Then we differentiate U with respect to x. That means our du is going to be equivalent to ln of x dx. ln of x, or du du dx is just going to, hey, what am I doing, guys? Sorry, now I'm lost. So du I'm sorry, ne? I'm very, very sorry. You know, sometimes math is not nice, guys. So du dx is going to be the derivative of this is just 1 over x. And then we solve for what? We solve for x. Okay. So what are we going to do here is that we are going to solve for x here on this. Yo, I'm sorry. We're going to solve for x here. So if we were to solve for x here on that first thing, remember the base, or the natural log always have the base e, right? Base e here. Base e. So if we were to solve for x here, our x is going to be equivalent to e to the power of u. E to the power of u. Makes sense, right? I hope so. I hope so. So we're going to have this one as e to the power of that one, e to the power u. So when we solve for x there, we're going to get that. So now let's try to make x the subject of dx subject of the formula here. When we make dx subject of the formula, we'll realize that dx is equivalent to x du. You understand? So we just cross multiply, and then we'll find that dx is equivalent to x du. And we know that our x is equivalent to e to the power u. Dx is equivalent to e to the power u du, like this. You understand? So now we've got everything in with respect to u. We can then rewrite our equation like this. So this is going to be integral of what? It's going to be integral of cos of ln of x. So this is cos of what? Is going to be cos of, where there is ln of x is equivalent to u. So this is going to be cos of u multiplied by what? By dx. So dx is equivalent to e to the power u multiplied by du, like this. So we've got e to the power u and what? And cos of u. So what do? We then use Liat. So now we've got two different functions. At least it's easier this way. So we've got our thing now. Now we can just apply Liat. You understand? So now we can identify our functions. We've got an exponential function and a trigonometric function. So we've got an exponential function and a trigonometric function. Trigonometric and exponential function. So according to Liat, the function that comes first, we differentiate it, and a function that comes last, we integrate it. You understand? So what does it mean? It means that now when we draw our cross here, we are going to do this. We are going to write the function that comes first here. The function that comes first here, according to the Liat order, it's the trigonometric function. So I'm going to write my cos of u, and then write my exponential function here. This is going to be e to the power u. So when we use our cross, we know from year to year we do what? We differentiate, right? So when we differentiate cos of u with respect to u, it's going to be what? It's going to be negative sine of what? Of u, right? And then we integrate e to the power u with respect to u is going to be e to the power u. It won't change. Then we apply our what? Our integration by parts now. So this is going to be, we copy the very same thing. So this is going to be cos of u e to the power of u, e to the power of u du. I copy it the way it is, and then now I apply my integration by parts. I say second multiplied by third, so this is going to be e to the power u, e to the power u multiplied by what? E to the power u multiplied by what? Multiplied by cos of u. My brain sometimes vice, multiplied by cos of u minus the integral of what? Minus the integral of second multiplied by first. So second multiplied by first, second multiplied by first. So this becomes negative e to the power u multiplied by sine of u. And then I write my du. Of course, now I'm integrating with respect to u. Then now I work better with what? With positive sign. So I'm going to take this negative sign outside the integral. So it's going to become positive. So it's going to force this one to become positive. And then I'm realizing that now I am having another integration by parts. So that means I'm going to integrate by parts again. So to integrate by parts here, this is what is going to happen. So I'm going to draw a cross again. And then I use my Liat. So what's happening here? I've got an exponential function and a trigonometric function. So according to the Liat, the function that comes first, we integrate it. So we differentiate it. So the function that comes first is our trigonometric function. So meaning that I'm going to write my sine of u here, and then my e to the power of u here. And then I differentiate. It becomes what? Sine u with respect to u. When I differentiate it, it becomes cos of u. And then I integrate e to the power u with respect to u. It becomes e to the power of u. Like this. Okay. I'm done now. So what's going to happen now is that I need to then apply my integration by parts for that integral now. So I'm going to recopy everything, of course, like always. So this is going to be e to the power u cos of u, e to the power u cos of u, e to the power u cos of u, cos of u. Why did I start with this? Let me write it the way I started it. I'm sorry, I don't want to switch things around. Now you're wondering, what is this guy doing? I don't want to look like I'm taking chances here. So e to the power u, I'm copying it again. So this is going to be cos of u plus, so this plus sign that I just wrote here comes from there, right? So now I then write that one. So this is going to be plus the integral of what? Plus the integral, oh, not the integral, I mean I open my bracket, I apply my integration by parts there. So with the use of this cross, of course, so this is going to be second multiplied by third. So this is going to be e to the power u multiplied by what? E to the power u multiplied by sine of u minus the integral of what? Of second multiplied by first. So this is going to be e to the power u multiplied by cos of u. You understand? Cos of u du. Then we close. Then we are almost done with it. So now I can see that, okay, I just need to multiply by the negative sign now. So when I multiply, I not just need to multiply by this positive sign. So when I multiply by the positive sign here, I'm still going to get positive this. And when I multiply positive again by that, I'm going to get negative that. So allow me to just eliminate these brackets, you understand? Because when I multiply by the positive, I'll still get the same thing. So I don't want to lengthen the steps for nothing. So that means I still have this. Then when I check, on my left hand side, I have integral of cos u e to the power u du. I have integral of e to the power u cos of u du, which is the same as that, meaning that I must then take my integral to my left then. So when I take it to my left, it's going to be 2, of course. 2 integral of what? Of cos u e to the power u du, like this. And then I have my e to the power u here, e to the power of u cos of u, e to the power of u cos of u, plus e to the power of u, e to the power of u sine of u, minus what? Minus the integral. Oh, that integral I already took it to the other side. What am I minusing it again now? What's wrong with me? Am I having some problems? Maybe. Okay, so now I know that my goal is to solve integral of cos u e to the power u du. I'm not supposed to solve 2 that, to understand? So I'm going to divide by 2 both sides, and then I'll be left with cos of u e to the power u du, which is equivalent to 1 over 2 e to the power u. One could just leave e to the power u the way it is. I don't know, what do you prefer? So let's see. It's up to us, basically. Yeah, we can just leave, we can again take out e to the power u as a common factor here, like so. We can just take it e to the power u as a common factor, and then open the bracket. We'll just be left with cos of u plus sine of what? Of u. And then I close. I now have my plus c. Okay, now that things are like this, let's then rewrite our question now with respect to x, because we're solving this question with respect to x, not with respect to u. You understand? The u was just introduced to make our life easier. So now that our life is easier, let's take it back to it being complicated. So we know that our u is equivalent to what? ln of x, and then e to the power of u is equivalent to x. That means where there is x, where there is e to the power u, I'm just going to substitute x. Where there is u, I'm going to substitute ln of x. You understand? So that means here I'm solving for what? Integral of what? Integral of cos of ln of x. You understand? Cos of ln of x, because ln of x is equivalent to u. E to the power u is equivalent to x. And then how about du? Du itself, it is equivalent to what? So if I were to solve for du here, it is equivalent to all right, or maybe I can just solve for e to I don't know, we can work with any of the two, but since already I've already substituted x, I don't know if I should just okay, let's just work with this one. It's fine. Let's work with the second one. So if we were to make du substitute of the formula here, that means du is equivalent to what? To dx over x. You understand? So du is equivalent to dx over x. Du is equivalent to dx over x. That's what I'm trying to say. So where there is du here, where there is du now, I'm going to substitute what? Dx over x. I hope that makes sense. So here I'm going to substitute dx over x. And then I do the same thing. Where there is e to the power u, I know it's equivalent to x, and then I copy same things here. So this is going to be cos of, where there is u, I substitute my ln of x, I close, plus sine of ln of x, again I close, and then plus c. Then I realize that on my left hand side I've got an x, and then they cancel out. I'll only be left with dx. So this and this cancel out. I am only left with dx. You understand? I'm only left with dx. And then tada, you reached to the correct answer. So it's gonna be the same thing as someone who uses the other explanation to work out this problem. Makes sense, right? So yeah, that's how it's supposed to be done. Now let's quickly check if we can solve other problems. Of course, we must be able to solve other problems. There are still some problems that we could solve. So yeah, just like this one here. We have, remember guys, what you're doing first there is to first pause the video before you attempt the question, and then like that we're gonna have a nice session. You understand? Woo, yeah. So now let's quickly do this one. You can see that we have two different functions, our algebraic function and our what is this, and our logarithmic function. So I could as well as first rewrite it nicely and say ln of x here, ln of x multiplied by x to the power of -2 dx, and then I write my Linear term. So so now we identify the two functions that we have. We've got an algebraic function and what? And a logarithmic function. You understand? We've got a logarithmic function and algebraic function. So this algebraic function, it's part of the a's there. So we've got this one. So we've got the logarithmic function, a logarithmic function, and an algebraic function. So according to the Linear, a function that comes first, we differentiate it, and a function that comes last, we integrate it. So I'm going to draw my cross, of course, like always, and then I write my ln of x here, and then I write also my what is this, my what is this, guys? What is x to the power -2? Sorry. Then I differentiate my ln of x. Of course, this is going to be just 1 over x, and then I integrate x to the power -2. It's gonna become x to the power, or -1 over x, isn't it? Yeah, it is -1 over x, because we're gonna add 1 here, we divide by -1, and then yeah, that's gonna be it. So that's going to be -1 over x, -1 over x. So that's it. We have -1 over x for that question. Makes sense, right? All right, it does make some sense. Okay, when we're here, we then apply our integration. So this is going to be therefore the integral of ln of x over x squared, ln of x over x squared. You copy it. That's the first thing, guys. That's the procedure. Then we apply our integration by parts. Second, multiply by third. That's going to be negative ln of x divided by what? Divided by x minus the integral of what? So first quadrant multiplied by third. So this is going to be -1 over x squared. -1 over x squared is the same as -x to the power -2 dx. I don't know. I hope you don't have a problem with that. When we multiply 1 over x and 1 over x, we get 1 over x squared. So it's the same as x to the power -2. I mean, is the same as x to the power of -2, and then the other negative comes that one. So I don't prefer working with this negative, so I'm going to take this negative out and then have a positive here. Makes sense, right? And then I copy the very same procedure again like always, and then I'm going to have my ln of x divided by x squared dx, which is equivalent to negative ln of x divided by x minus what? So it's going to be negative because of we're going to add 1 here, and it's going to be -1. It's going to be -2 plus 1 is still going to be -1. We divide by that -1, we end up getting -1 over x and then plus c. So I hope you're not having a problem when it comes to differentiating, guys. These are basics. We have done this countless times in the previous videos. So if you forgot, you can kindly go back to my videos. So yeah, that's just it. I hope you you understand it. Again, here one would say I want to take 1 over x as a common factor. You could still do it, and then you will have 1 over x, or if you can take it as a negative, it's going to be negative 1 over x ln of x plus 1 in brackets there. So I'm not gonna do it. I'm just gonna leave it there. Or should I do it? Let me just do it, Jeff, just because of some people might have problems, people like me. Ln of x plus 1 and then plus c. Ta-da! It's still the same answer. So even if you got this or that one, both of them are the same answers for that question that we're trying to solve. All right, let's quickly see if we can solve another one. Okay, we've got this question here. All right, we now have this question is the same as well. It's the same as well, like the procedure is the same. So we're still gonna use Liat. Okay, so I'm gonna draw my cross, of course. Of course, we need to first identify which functions are we dealing with. So we've got an algebraic function and a hyperbolic function. What you need to remember is that algebraic functions are the same as exponential functions. So this is very important. This question is very important. Hyperbolic functions, you need to remember that they are the same as exponential functions. So you need to remember that you are dealing with an exponential function. So hyperbolic functions, they fall under exponential functions here, under the family of exponential functions. So that means we're dealing with an algebraic function and an exponential function. So here we've got an algebraic function and an exponential function. So according to the Liat rule, the function that comes first, we differentiate it. So the function that comes first here is the algebraic function. So x squared comes first, we differentiate x squared. And then hyperbolic function, we're going to write it here. Hyperbolic function, we're going to write it here. Makes sense, right? So we're going to differentiate x squared. When we differentiate x squared, it's going to become 2x. We integrate hyperbolic sine of x, it becomes hyperbolic cos of x. And then we're done. We then apply our integration by parts. This becomes x squared hyperbolic sine of x dx, and then we copy that. So it's going to be second quadrant multiplied by the third quadrant. That's going to be x squared multiplied by hyperbolic cos of what? Of x, right? Minus what? Minus the first quadrant multiplied by third quadrant. That's just going to be 2x multiplied by hyperbolic cos of x dx, right? Then we realize that, we've got another integration by parts, so we don't panic. We're now used to it, right? We're now used to it, so we just apply it again. So we're gonna identify our functions. The function will still have algebraic function and a hyperbolic function. So we're going to differentiate 2x. We're going to differentiate 2x, and then here we write our hyperbolic cos of x. So we differentiate 2x, it becomes what? It becomes a 2. We integrate hyperbolic cos of x, it becomes hyperbolic sine of x. Then that's it. That's just it for that one. And then from there, we then apply the integration by parts for this one. So I'm going to copy everything and then apply integration by parts for that one. So this is going to be x squared hyperbolic sine of x dx is equivalent to x squared hyperbolic cos of x minus what? Then I open the bracket. The minus that I wrote here already is this one that's here, right? So I hope you're not having a challenge with that. So now I'm going to say second quadrant multiplied by the third. So that's going to be 2x, which multiplies my hyperbolic sine of x, hyperbolic sine of x, minus what? The integral of 2 hyperbolic sine of x, hyperbolic sine of x, just like that, and then dx there. I close. So Of course, I can take these two outside the integral to make my life a lot easier, or to make things look nice, you know. So I took it out. Then what I'm going to do now is to copy everything back again. And then, so this is going to be x squared hyperbolic sine of x dx is equivalent to x squared hyperbolic cos of x minus, and then I open my bracket. I'll multiply by the negative sign after, guys. So I'll multiply by the negative sign after. So this is going to be negative 2x hyperbolic sine of x, and then minus, now I integrate this one. So minus 2, when you integrate hyperbolic sine of x, it remains as hyperbolic cos of x. And then you close, and then we say plus c. So now when we multiply this negative by these two terms, this one is going to become negative and this other one is going to become positive. So allow me to just write positive here and then eliminate the brackets, and then plus c, of course, plus c. Then we're done. We're done. Ta-da! So yeah, that's it for that question. Of course, one of you could say, I want to take cos of x as a common factor for the 2, and then I'll end up having x squared plus 2 multiplied by cos of x. You can do that. I'm not going to do it. It's you who wants to do it, so you can do it because you want to do it. Who's going to stop you? So yeah, let's quickly see what we can do to this other question here. We still have other questions, so yeah, we now have this question, e to the power x multiplied by cos of x. So we should again integrate it. We should integrate this question. So what we are realizing is that we've got a product of two different functions. So we need to do it. We need to identify. We need to first check that can we make one f of x and the other one be f prime of x? Then you'll realize that no, it's not possible. So what are we supposed to do? We're supposed to apply integration by parts. So Liate is gonna come. It's gonna come. Liate. Okay, then you draw your cross. After drawing your cross, you then you then identify the different types of functions that you're dealing with. So for this case, we are having an exponential function and a trigonometric function. So we've got an exponential function and a trigonometric function. According to the Liate, a function that comes first, we differentiate it, and a function that comes last, we integrate it. So this is going to be our, we're going to write our cos of x here. So cos of x is going to get written here. And then our e to the power of x, we're going to write it there. And then we do the differentiation. So when we differentiate cos x, it becomes negative sine of x. It becomes negative sine of x, e to the power x. When we integrate it, it remains as e to the power of x. Makes sense, right? Okay. Then now we can apply our integration by parts. So now we copy it the way it is, or we copy the equation the way it was given to us. Cos of x multiplied by dx is equivalent to what? We say second multiplied by the third quadrant. So this is going to be e to the power x multiplied by cos of x minus the integral of what? Minus the integral of negative e to the power of x sine of x. I hope you don't have a problem with how I got that one. I just multiplied the third and the first quadrant like always, and then the negative always goes with the integral sign always goes with me, as well as the negative outside. That's part of the integration by parts rule. Okay. All right, I don't like working with this negative here inside. I'm going to take it out, and then I'm going to have a positive sign here. Makes sense, right? So I took it out. I now have a positive sign outside. Then I realized that, I'm still dealing with an integration by parts. So what do? I draw my cross. I don't panic, but I draw the cross, right? Instead of panicking, I draw the cross. Okay, I realize that, I still have a trigonometric function and an exponential function, meaning that I still need to do the same thing. I need to differentiate the trigonometric function, cos is the one that comes first according to the Leiter order. And then e to the power x, I'm going to write it here. Then I differentiate my e to the power x. How does my sine to the power x, how much does it become? Oh, yeah. How much? How does it become? It becomes what? It becomes cos of x, right? Cos of x. Then we integrate e to the power x. It becomes what? It becomes e to the power x. It doesn't change. And then now I copy again everything the way it was. So this is going to be e to the power x multiplied by cos of x dx, which is equivalent to e to the power of x multiplied by cos of x, yeah? Cos of x, like this. And then I say plus. So this plus is this one, right? I always copy that sign there. So now it's my time to apply integration by parts. So I'm going to say I'm applying integration by parts for this integral. So this is going to be second multiplied by the third quadrant. So this is going to be e to the power x. It's going to be e to the power x multiplied by what? Sine of x. Okay, minus the integral of first quadrant multiplied by the third. So this is going to be e to the power of x cos of x dx. And then I close. Like always, we can already say that, okay, this integral is the same as that one on the other side. So if we were to solve this again, that means we were gonna go through the same steps again. So let's not do that. So what I'm gonna do now is just to multiply by this positive sign across this entire bracket. So this positive sign will multiply this term and this term. So it will end up, so when I multiply this positive by this one, it will end up becoming a positive this term, and then we'll multiply the positive by that, it will become negative. So meaning that I can just remove these brackets, right? I will still have the same thing. Make sense? All right. Then for the second step, I'm going to take this guy to my left. So when you take that guy to my left there, it's going to become 2 integral of e to the power of x multiplied by cos of x. Oh, so I have done this one basically there, up there, right? I remember this one, I did it. I don't know why I repeated it. I'm sorry, guys. Now it just crossed my mind that now I did this under the examples. So I'm sorry, guys. I'm sorry. But it's good that we did it. What if when you had already forgotten, now you're getting chopped, you're surprised that, what is this now? So it's good that we're doing it again. Okay, I'm gonna copy the same thing, or I can just take out e to the power x as a common factor for these two, and then I'll have cos of x, which adds what? Sine of x. Sine of x. And then I close. I've closed now. Then I'm going to divide by 2 on both sides. When we divide by 2 on both sides, we'll end up having the integral of e to the power of x cos of x multiplied by dx is going to be equivalent to 1 over 2 e to the power of x multiplied by cos of x plus sine of x. And then you close, you say plus c. Ta-da! You're done with that thing. So yeah, we're done. Done. I hope you're getting it there as well, because you can't be cruising there. You must be getting these things, guys. You must be getting these things. Okay, now we have what? We have this question. So this question, we have integral of x multiplied by sec squared of x dx, right? So we've got an algebraic function and a trigonometric function. Let's see. So we've got linear term. So we've got our thing there, Liat, that we're gonna use. So if we're gonna draw our cross, of course, and then we identify the types of functions that we're dealing with. We're dealing with an algebraic function and a trigonometric function. So what are we gonna do? We're gonna write our x here. Okay, so an algebraic function comes first before the trigonometric functions. Hence, we took x as the thing that we're going to differentiate, and this one, sec squared of x, we're going to integrate. So when we differentiate x, it becomes 1. When we integrate sec squared, it becomes tan of x. And then from there, we apply our integration by parts. This is just going to be, we copy same thing. So x multiplied by sec squared of x dx is going to be equivalent to what? X multiplied by tan of x minus what? Minus the integral of what? Of third. Okay, I hope you're not having a problem with x tan x. I said first multiplied by third, second multiplied by third, like always. The procedure is the same, guys, so you don't have to panic. And then third, first multiplied by third now. So this is going to be just tan of x. Tan of x dx, like that. And then after that, we just need to then integrate. We know that when we integrate tan x, how much does it become? We know that when we integrate tan x, it becomes how much? ln of sec x, right? It becomes ln of sec x. So I'm gonna copy the same thing here. So it becomes I'm copying now. I'm copying ln of sec squared of x dx equals to x tan of x multiplied by integral of tan x is going to be this negative ln of what? When we integrate tan x, it becomes ln of sec of x. So ln of sec x plus c. Then you are done with that question. You are done with that question, done and dusted. So that was it for that question. I hope you got it. You should have gotten it, of course. So yeah, now that you got that question, what can we then do? Okay, what can we then do? We can do another question. Yeah, we can do another question. Yeah, we can still do that. Yeah, we can do that. But yeah, guys, you can. I hope by now you can see that. Yeah, we can really different. We can integrate these things, and they are easy, right? So now it's just another time to do this one. I hope you're also getting them, because I believe by now, before any question, you are trying to pause the video and then you attempt it in your own. Guys, it's not a movie, it's a lesson. So it's a lesson whereby you're also supposed to be working there. So you can't be cruising, guys. You should also work. You understand? So work, and then we're gonna be on the same page. So now that we've got another question to do, let's quickly attempt it. So when we check here, we've got this integral of x cubed e to the power x squared dx. We can see that even if we were to make one f of x here, the other one can be f prime of x, is gonna fail. So it tells us that we need to use integration by parts. So on integration by parts, we're gonna have a problem. If we use integration by parts directly here, then we're gonna have a problem, right? Because of, look at it. Of course, we have an okay, I'm gonna write down the Liate like always. Liate. So when I now that I've written my Liate, we need to then draw our cross, right? So now that I've drawn my cross, we then identify the type of functions that we're dealing with. So we've got an algebraic function and an exponential function. So the problem is on this exponential function, okay, we've got an algebraic function. Okay, that's correct. That's correct. And then we've got an exponential function. Now, if we were to then follow the Liate rule directly here from here, we're going to put our x cubed here, because it's the one that comes first, and then our exponential function, it comes last. You understand? So look at it. Okay, we can be able to differentiate x cubed is going to be 3x squared, right? That's true. But how about e to the power x? Can we integrate it? Definitely no. We have a big matata. We have big matata. So with this big matata, what can we then do? We then need to then realize that, okay, why don't we just rewrite our given integral in a simple way, meaning that we're going to use u substitution to rewrite this equation in a nice way. Okay, all right, stay tuned. So this is how it's going to be. So from here, we're going to say this. We're going to say x squared. We're going to split this because I can see that, all right, x squared and x squared somewhere, somehow. Since I know that I want to let u to be my x squared, so I'm gonna split this, right? I'm gonna say x multiplied by x squared. Hey, wait, no man, what's wrong with you? X squared multiplied by x multiplied by e to the power x squared dx. So I just rewrote that given equation in this following manner. Okay, so now I'm gonna let my u to be equivalent to x squared. So from here, I then differentiate this u. So this is going to be du dx is going to be equivalent to just 2x, right? So my du dx is going to be equivalent. So I try to make dx out of the formula from here. So therefore, dx from there is going to be equivalent to what? To 1 over... is going to be equivalent to du over 2x, like this. So my dx is going to be equivalent to du over 2x. So now I can try to substitute everything there in the in that thing. Okay, all right. So now when I substitute there, it's gonna be as follows. So now I'm substituting back, or I'm rewriting my equation with respect to u. So where there is x squared, I'm gonna substitute with u, and then where there is dx, I'm gonna substitute by what? By a du over 2x. So yeah, so here I'm gonna write my u, and then where there is e to the power x squared, I'm gonna write it as e to the power of u. You understand? E to the power of u, just like that. So now that we're here, I have x and what? And dx, I know that dx is equivalent to, so dx is equivalent to du over 2x. Du over 2x, meaning that the x and the x here, the x and the x, they're gonna cancel out, and then we're only gonna be left with du over 2. So let me write it as du. So allow me to just write du, and then write, maybe I can just put the 1 over 2 here or here. It's fine anyway. But let's write it where? Let's just leave it here. It's fine. We can just leave it inside there. We can just leave the du inside there. You understand? Okay. Now that you understand, then we can quickly just solve this question. Or we can take the 1 over 2 outside. It's still fine. It's still fine. Or we can leave it here, whatever. What do you guys prefer? Yeah, let's just leave it there. It's fine there. The 1 over 2, it's even fine there. So now that we have this, so now we can see that we've got an exponential function and a nice algebraic function. For this case, we're again going to use the Leerte. Okay, so now it's where then the Leerte is going to be applicable nicely. So our e to the power u obvious is the function that comes last, so it's going to be written there. Then our 1 over 2 u is going to be written here, and then what can we do from there? Then we differentiate. We'll still be left with 1 over 2. We integrate this e to the power u. It remains as e to the power of u. Then we apply our integration by parts. So I'm gonna write down this. So this is going to be 1 over 2 multiplied by u multiplied by e to the power u. The u is going to be equivalent to what? So I will apply the by parts now. So I copied it. So this is going to be second multiplied by the third. So it's going to be 1 over 2 multiplied by u multiplied by again e to the power u minus the integral of 1 over 2 e to the power u du. Then one could say, let's take the 1 over 2 outside the integral here. Then it's going to be what? It's going to be just 1 over 2 outside the integral there. Then we apply the integral there. So this is going to be, oh, I can continue copying everything like always. Ne? I can continue. So I'm going to continue copying. So this is going to be 1 over 2 u e to the power u du like that. And then this is going to be equivalent to 1 over 2 u e to the power u. I just copied it, didn't do any damage. Now I integrate e to the power u. It remains as e to the power of u. Then I write my plus c. Then now it's time to write rewrite everything with respect to x, because we're differentiating with respect to x. So where there is u, we're going to write x squared, and then where there is dx or du, we're going to write 2x times dx. Where there is du, we're going to write 2x over 2x multiplied by dx. So okay, so this is how it's going to be. I have my 1 over 2. Where there is u, I say that I write my what? My x squared. And then when there is e, where there is u again, so this is going to be e to the power what? X squared. Where there is du, I write 2x multiplied by dx, which is going to be equivalent to, I substitute everything again this side. I'm gonna have my x squared multiplied by e to the power of x squared minus 1 over 2 e to the power of x squared there, multiplied by what? Oh, this char, then plus c. Then from here we can see that, okay, the 2 and 2 will chop each other, and then x squared multiply x will go back to x cubed. So we'll go back to x cubed multiplied by e to the power of x squared dx, which is equivalent to, on this other side we can just take out 1 over 2 e to the power x squared as our common factor. So 1 over 2 e to the power of x squared as our common factor, and then we'll be left with just x squared minus 1 plus c. Ta-da! You have your final answer. So that's just it for this question. I hope you got it. I hope you got it. It's very easy. It's very easy. It's very easy. So we have another one here. We have another question. So let's quickly solve it and then we'll be fine. I hope you are still pausing the videos before you attempt any question, so that you can check if you are getting the concepts, because of you need to get the concepts. You need to get what is happening here. Okay. Now we've got our integral of inverse hyperbolic sine of x dx. So we're supposed to integrate it as well. So to integrate this, we need to use Lyaté, okay? We're going to use Lyaté like always. Lyaté is very applicable every time. Every time we should always make use of Lyaté. All right. Okay, so let me write the Lyaté first. Lyaté. All right, then I draw my cross. I draw my cross. And then now it's time to identify the type of functions that we're dealing with. I say the other one every time, it's a 1. So we've got 1 there, which is part of the algebraic functions because of it has the x to the power of 0. So we've got what? Inverses. We've got an inverse and an algebraic function. So inverses, so according to the Lyaté, inverses will comes first. So that means we're going to write sine inverse of x here. and then our 1, we're going to write it here. Then we differentiate our sine inverse of x. We make use of what? Of our differentiation rules. That means this one takes us back to differentiation when we differentiate inverse trig function. So this one is going to become 1 divided by square root of 1 minus x squared. Just like that. Then we integrate 1, it becomes x. Then we copy down everything. Now we apply our integration by parts. So the integral of that is going to be sine inverse of x dx is going to be equivalent to what? To sine inverse of x divided by x, right? Or multiply by x. I mean, so it's going to be x sine inverse of x. Sine inverse of x. Causes, what did I do? I multiplied my second quadrant multiplied by the third. Then we continue with our integration by parts. We say minus from the rule, and then integral of what? Integral of x divided by the square root of 1 minus x squared dx. So that's it. So now you've got your integral of x divided by 1, x divided by square root of 1 minus x squared. So that's it for that part. So now we need to integrate this. Then this one, when we check it, it's a quotient, right? It's a fraction. So we check if we first check if it fits to be one of the inverses. So we realize that now it doesn't fit to be one of the inverses. So we check if we make one f of x, can the other one be f prime of x? Then yes. If we make the denominator or what's inside the radical signs to be f of x, then the numerator can be the f prime of x, understand? So meaning that a general power rule is going to be applicable here. So let me just recopy down everything again and then rewrite it nicely. So this is going to be sine inverse of x dx, which is going to be equivalent to just x. I'm just copying for this part. I want to rewrite this part nicely. So I'm going to write my x here and then rewrite this one. So this is going to be 1 minus x squared. I'm going to take that one up. So the first thing is to take the square root up. So it's gonna change, of course, the exponent. If I rewrite it in exponential form, it's gonna change the sign of the exponent. So that's going to become negative 1 over 2 dx. So I can see that I can use general power rule since I decided to make this one f of x. So I know that when I differentiate this one, I get negative 2x, right? So I have x here, so I need to correct the coefficient by just writing negative 2 here, and then cancel out this negative 2, cancel out the negative 2 by multiplying by negative 1 over 2 outside the integral, so that this and this can cancel out. So according to general power rule, when you have f prime of x here, and here you have you have f of x, and your n here it's not equivalent to negative 1, then you can use general power rule and only take the f of x and say and add plus 1 divide by n plus 1, of course. So I'm going to copy down everything again. So this is going to be inverse sine of x dx is equivalent to what? To x sine inverse of x sine inverse of x. So this one, so this negative will multiply this negative 1 over 2. I'll end up having positive 1 over 2, right? And then I apply my general power rule. General power rule says that you only take the f of x there, and then you add 1. So when we add 1 on the exponent there, we're going to get positive half. So this is going to be positive half divided by what? By that positive half, and then plus c. And then this positive half is going to chop, or this 2 here on the denominator will chop this half here, and then that will be it. So let me just copy down everything again. Sine inverse of x dx is equivalent to x sine inverse of x plus square root. So this is going to be square root of 1 minus x squared plus c. Ta-da! You have your answer. So that's just it for that question that we were dealing with just now. So that's it. That's it. That's how it's supposed to be done. That's how it is supposed to be done. Okay. Okay. Now that we are done, we need to just we've been solving. Okay, now let's solve other questions then. Other questions, and then we'll wrap it up. Okay, let's then integrate this one. Remember yourself there, you are pausing the video so that you attempt this question and then you see what's happening. So we've got two different functions here multiplying each other, so we need to use product rule. So I'm gonna write my Leerte down, and then I draw my cross. After drawing my cross, I identify the different functions that I'm dealing with, only to find that I've got an algebraic function and a logarithmic function. So I've got a logarithmic function and an algebraic function, you understand? So logarithmic function comes first, so this is going to be ln of x. And then x squared comes last, because it's part of the algebraic. And then I differentiate ln of x, it becomes 1 over x. I integrate x squared, it becomes what? X cubed over what? Over 3. Just like that, right? It becomes x cubed over 3. And then we're done. Then now it's just a matter of now applying my integration by parts. So I'm going to copy down my equation like always. So this is going to be ln of x dx, which is equivalent to, I say, my second quadrant multiplied by the third. So that's going to be 1 over 3 x cubed. So this is going to be 1 over 3 x cubed multiplied by ln of x. Minus what? Minus the integral of second multiplied first multiplied by third. So that's going to be 1 over 3. I can already take it outside the integral, and then we'll be left with x squared there inside the integral, because of when we multiplied x cubed multiplied by 1 over x, one of this x is going to get chopped there, so we'll only be left with x squared. And then the 1 over 3, I already took it outside the integral. I hope you don't have a problem with that. Then now I can see that okay, I'm only supposed to integrate that one. So this is going to be x squared ln of x dx is going to be equivalent to, I copy this, so I'm copying 1 over 3 x cubed multiplied by ln of x, and then minus what? Minus 1 over 3, of course. Then I integrate my x squared, it becomes what? It becomes x cubed over 3. So it becomes x cubed over 3. X cubed over 3, like that. So that x cubed over 3 multiplies that other 1 over 3 there, then plus c. And then that will be it. One of you can decide to take 1 over 3 as a common factor. It could also work. You can decide to take 1 over 3 as a common factor, or 1 over 9. If you take 1 over 9 as a common factor, then for this one you'll have to put a 3 inside the brackets, but it will be up to you, definitely. I'm gonna stop there. Yeah, let me just leave it there, and then we continue. Okay, we have this one now. We have this one. So I hope what? Yeah, these things are long. I wanted to finish. I want to finish. I want to finish. Okay, yeah, now let's quickly do this one then. We now have this one that I projected there on the screen. We have got integral of cos x multiplied by the hyperbolic sine of x dx. Of course, we can see that these are two different functions that are multiplying each other. And if we were to make one f of x, then the other one can be f prime of x. Understand? So meaning that we can just make use of integration by parts. So I'm going to write down my linear term. Understand? So when I write down my linear term like this, I'm going to draw my cross thereafter. After drawing the cross, I then identify which type of functions am I dealing with here. So I find that I'm dealing with a trigonometric function and a hyperbolic function. And we know that hyperbolic function is part of what? It's part of the exponential functions. I forgot to mention it, of course, when I was starting my video there up there. I should have done that, but I'm sorry. At least I'm explaining it now, so it's still I'm still safe. It's still early. It's not late. I hope so. Okay, yeah, so that's it. That's it for that one. So since we've got a trigonometric function, so that means we have a trigonometric function and an exponential function. So that means we're going to differentiate what? The trigonometric function, which is cos of x, and then integrate what? Integrate hyperbolic function. Integrate that hyperbolic function. And then just like that. So let's differentiate the cos of x. It's gonna become negative what? Negative sine of x. Like that. And then we integrate our hyperbolic sine of x. It becomes hyperbolic cos of x. Just like that. And then now we apply our integration by parts. So we first copy the equation the way it was given to us. So this is going to be cos of x multiplied by sine of x. Just like that. Dx, of course, we shouldn't forget it. And then we equate it to what? We say, now we apply our integration by parts. So it's going to be this multiplied by this. So there's going to be cos of x multiplied by hyperbolic cos of x. So it's going to be cos of x multiplied by the hyperbolic cos of x minus what? Minus first quadrant multiplied by the third quadrant is going to be negative sine of x multiplied by the hyperbolic cos of x, like that. Then I have my dx, of course. So I'm going to take out this negative sign outside the integral. So when I take that negative sign outside the integral, it's gonna cause this one to become positive. Then I erase it there. Then I realize that, okay, I still have another integration by parts. So meaning that I should continue with my integration by parts. I shouldn't panic, but instead draw a cross. So when you draw a cross, you still use linearity. You'll realize that you're dealing with a trigonometric function and a hyperbolic function. So sine x is gonna get differentiated. So you're gonna differentiate sine of x, and then hyperbolic cos of x, you are going to integrate it instead. So hyperbolic cos of x, you are going to integrate it instead. So when you differentiate sine x, how much does it become? It becomes cos of x. So this becomes cos of x. And then when you integrate hyperbolic cos of x, how much does it become? It becomes hyperbolic sine of x, of course, hyperbolic sine of x. All right. Now that we are done with the cross, then we apply our integration by parts for this one, right? For this one, we're going to apply integration by parts for this integral. So okay, so I'm gonna copy down everything. Here. So this is going to be cos of what? Cos of x. Cos of x multiplied by sine of x. So hyperbolic sine of x, hyperbolic sine of x dx, which is going to be equivalent to, so I still copy my cos of x multiplied by the hyperbolic cos of x, and then I say what? Plus, so this plus sign that I just wrote comes from here, right? I just copied that positive sign, and then after that I'm gonna do what? I'm gonna open the bracket. So I open the bracket, then I apply that integration by parts for this integral. So it's going to be this second quadrant multiplied by the third, so it's going to be sine of x multiplied by the hyperbolic sine of x minus what? Minus the integral of cos of x of course, cos of x multiplied by the hyperbolic sine of x dx. Then I close. Alright, so here you're going to realize that, okay, on my equation I was integrating integral of hyperbolic sine of x multiplied by cos of x, which came back here when I'm busy trying to solve it. So meaning that I need to take it to my left hand side, and then that will be it. So before I take it to my left hand side, I need to first multiply by this positive. So when I multiply this positive by these two terms, this one is going to remain as positive, and then this other one is as well is going to remain as negative. So allow me to just eliminate these brackets again. Allow me to just eliminate this bracket so that I avoid writing a lot of steps unnecessarily. So I'm going to take the other one to my left hand side. Then that's going to be 2 integral of what? Of cos of x multiplied by the hyperbolic sine of x dx, which is equivalent to, I now copy down what is on my right hand side. So this is going to be just hyperbolic cos of x multiplied by hyperbolic cos of x, of course, plus sine of x multiplied by the hyperbolic sine of x. And then that's it for that one, because we've already taken that one to the other side. Then from here we divide by 2 on both sides. Then we'll just be left with the integral that we were trying to solve. So that's what? My cos of x multiplied by my hyperbolic sine of x dx, which is equivalent to what? To cos of x multiplied by hyperbolic cos of x plus sine of x I am writing sine, sorry, sine multiplied by the hyperbolic sine of x. Yeah, so of course this is being multiplied by a negative, a 1/2, because I divided both sides by negative. So let me just create some space by trying to move it to the left. Okay, like that. So this one is being multiplied by half, like this, because I divided both sides by 2, right? So it's multiplied by half. Then of course I shouldn't forget my plus c. So that's it for that question. I solved it like that. So now we need to then redo this, do another question. So I hope you also got this one. That was it for that question. I hope you got it. It was an easy one, really. It was an easy one. Let's quickly see if we can solve another one there. Okay, we have this other question, integral of cot inverse of x multiplied by an x. So what are we supposed to do? We've got okay, wait, let me just position this well to leave enough space. So I'm always worried about the question that follows, so that's why I always move my questions up. It's because of I don't know how much space I'm gonna use, so I always need to position my questions well here in this thing. So Yeah. So again, on this question, we've got a product of two different functions, whereby if we were to make one f of x, the other one can be f prime of x. So we need to then use our integration by parts for us to be able to integrate the question that we are dealing with. Okay, so that's what we are going to do. So to do that, we need to first write down our Liate. So I'm going to write down my Liate here. So this is going to be my Liate. Okay, now that I wrote down my Liate there, then I can then draw my cross. So to draw the cross, I'm going to draw the cross here. So here's the cross, it's draw. Okay, so I need to identify the type of functions that I'm dealing with for this question. So I've got an inverse trig function, and also I have I've got an algebraic function. So according to the Liat, the inverses comes first before the algebraic function. So what am I gonna do? I'm gonna differentiate the inverse. So the inverse, I'm gonna write it here. Cot inverse of what? Cot inverse of x. And then the x, I write it here. So when I differentiate my cot inverse of x, I need to just remember the differentiation formulas. So this one should become -1 divided by what? Let me write it nicely. -1 divided by what? Divided by 1 plus x squared. So -1 divided by 1 plus x squared. 1 plus x squared, like that. And then I integrate my x. So when you integrate x, it becomes x squared over 2. X squared over 2. Okay, now that I have my cross, then it's easy. I just need to then follow my what is this? Follow my what is this, guys? Follow my integration by parts rule. So I'm gonna copy down the equation. So you copy down the equation, it's going to be x multiplied by the cot inverse of x dx, and then you equate it to what? You equate it to the application now. So this is going to be a second quadrant multiplied by the third. So that's going to be x squared over 2. So that's going to be x squared over 2 multiplied by the cot inverse of x. Cot inverse of x minus what? Minus the integral of what? Of 1 over 2 multiplies that. So I can already leave the 1 over 2 outside the integral to simplify my life. So I'm going to leave the 1 over 2 outside, and then I'm going to have negative what? Negative x squared. Negative x squared over 1 plus x squared. 1 plus x squared, just like that. And then I have my dx here, of course. So what I'm gonna do now is just to take this negative sign outside the integral. So it's gonna force this one to become positive, and then this negative sign, it's now removed. Okay, so what I'm realizing about this integral is that I've got the degree of the numerator is the same as the degree of the denominator. So meaning that I'm supposed to use a long division method, or I cook it. So I'm gonna use the method of cooking. So I'm gonna say x squared plus 1 minus 1. You understand? So if you forgot the method of cooking, I explained it well nicely in my previous video. So you can kindly go back to my previous videos. You will get reminded of how to really work out the method of cooking if you don't want to go with long division method. So yeah, That's what I did. So what I'm gonna do now is just to split now. So I'm gonna split. So let's copy everything down again. So to copy down everything again is gonna be like this. It's gonna be x multiplied by the cot inverse of x multiplied by dx. It's equivalent to what? It's equivalent to x squared over 2 multiplied by the cot inverse of x. So multiplied by the cot inverse of x, multiplied by cot inverse of x, and then plus what? Plus now I said I'm gonna split, right, for the other side. So I'm gonna split. So x plus 1, I'm gonna make x squared plus 1 to have its own denominator, as well as minus 1 to have its own denominator, meaning that at the end of the day I will have integral of x squared plus 1 divided by 1 plus x squared, yeah, like that, over, okay, multiplied by dx, yeah, minus 1 over 2 integral of what? Of 1 divided by 1 plus x squared dx, just like that. So that's it for that question. So now the thing that we are supposed to do is just to integrate. Then from here is just to integrate. So we can say that, okay, for this case, x squared plus 1 and x squared plus 1 will cancel each other. So meaning that I'm just integrating 1 here. I'm just integrating 1. And then here is going to be tan inverse, because of I can see that 1 is the derivative of x here. So meaning that this is the inverse. So we have done a lot of inverses before, integration of inverses. So if you forgot them, you are welcome to go back to the previous videos, and then you will get reminded there. So cot inverse of x dx is going to be, so now I'm just copying, right? So this is going to be x squared over 2 multiplied by the cot inverse of x plus so here we're integrating what? It's more like integral of 1. It's more like integral of 1 dx, understand? So we're integrating 1. So that's is gonna be the same as 1 over 2 multiplied by x, right? And then for the other one is going to be minus 1 over 2 tan inverse of what? Of x. Tan inverse of x, minus 1 over 2 tan inverse of x plus c. Then we are done for that question. So that's it for that question. So let's quickly see if we can solve another question. I hope you also got this one, because it was easy, right? It was very easy. So I hope you got it, guys. It was an easy one. So let's quickly see if we can solve another now question. We're supposed to integrate x cos of 5x minus 1, and when we check, we cannot be able to make one to be f of x and the other one be f prime of x, meaning that we're going to go with integration by parts as well for this question. So let's write down our Liat to help us to identify which one will lead to be our function that we differentiate and the function that we integrate. So I'm gonna write down our Liat. Okay, then I write down the cross, of course. So after this, we then identify the different types of function that we are dealing with. So I've got an algebraic function, and cos, of course, it's part of the trigonometric function. So I've got an algebraic function and one of the trig functions here. Understand? So the algebraic function is the one that I'm going to differentiate, and the trigonometric function is the one that I'm going to integrate because it comes last. So I'm gonna have my cos of 5x minus 1. Yeah, I should write it nicely. Sorry, let me write it nicely. Cos of 5x minus 1, just like that. So now when I differentiate my x, it becomes what? It becomes 1. When I integrate this becomes 1 over 5 sine of 5x minus 1, sine of 5x minus 1, just like that. So now that I have my cross, I can then just apply my integration by parts by first copying down the equation. So this is going to be cos of 5x minus 1 dx, which is going to be equivalent. I hope you didn't have a problem with integrating this one. We've dealt with integration of what? Of trigonometric functions. So the very same way I explained this, the very same way I applied here. So I just went quick. I just did it quick course of what I'm assuming that now we are all comfortable with integrating that. So yeah, let's just now apply the integration by parts. So this is going to be the first quadrant multiplied by the third quadrant. So this is going to be x over 5. X over 5 multiplied by what? X over 5 multiplied by the sine of 5x minus 1 multiplied by sine of 5x minus 1. Then minus what? Minus the integral of first quadrant multiplied by the third quadrant. Then that's going to be, I can already take the 1 over 5 out, and then integral of sine of 5x minus 1 dx. So what did I do for this part? I said second quadrant multiplied by the third quadrant. I got this. For this one, I say minus first multiplied by the third. Then I got this. I already took the 1 over 5 out. So now I'm left with this. So now I'm supposed to integrate this. For me to be able to integrate this, I need to make sure that I have the derivative of what? Of the argument here. So when I differentiate the argument, I know I should have 5 here. So I need to cancel out that 5 by writing out another 1 over 5 outside the integral. So the 5 and the 5, they cancel out, and then myself, I'll be able to integrate that. So let me just continue copying everything here. So this is going to be x cos of 5x minus 1 dx, which equals to x over 5 sine of 5x minus 1, sine of 5x minus 1 minus, now I integrate this. So if I have the derivative of the argument and this trig function, then I can then conclude that I ask myself, what is it that was differentiated for me to get positive sine? It's what? It's negative cos, right? So that negative cos will multiply with this negative that's outside the integral, or end up having positive 1 over 25 cos of what? Cos of 5x minus 1, then plus c. Ta-da! I have my answer. So that's just it for that one. It was easy. One could decide to take 1 over 5 as a common factor. It can still work as well. It can work as well. Or 1 over 25 as a common factor. Whichever you prefer, one of them, it's still correct. It's still correct to do that. You're allowed to do that. Okay, we have another one here. We have another question here, which is our second last. So to do this, we can see that we have it's just the integration of what? Ln of x squared plus 2. So we know that whenever we integrate something like this, whereby we have only one logarithmic function, we still use Liat, and we treat our function, our other function, as the one here that is here. So we then draw our cross, and then we have our two function, one which is part of the algebraic function and the logarithmic function. So we've got the logarithmic function and the algebraic function. So according to the Liat order, the function that comes first, we differentiate it, and the function that comes last, we integrate it. So we have the logarithmic function that I'm going to write here, ln of x squared plus 2. And then we have our 1 here. So when we differentiate ln of x squared plus 2, what do we get? We get 2x divided by what? By x squared plus 2. Then we integrate 1, we get our x here. Make sense? Yeah, it should make some sense. It should make some sense. And then from there, what are we then going to do? We're then going to do the following. We're going to apply our integration by parts. Now we are going to copy this. This is going to be ln of what? Of x squared plus 2. So this is going to be ln of x squared plus 2 dx is equivalent to what? Is equivalent to, I say second quadrant multiplied by the third. So this is going to be x multiplied by my ln of x squared plus 2. X squared plus 2 minus what? Minus first multiplied by the third. So when I multiply my second and third, I get what? I get 2x squared divided by what? Divided by x squared plus 2 dx. You understand? When I multiply my third and first, okay? I get that. So now it's about time I integrate this. So when I check this, the derivative, the degree of the numerator is equivalent to the degree of the denominator. So meaning that I can use long division method for me to be able to integrate this. Or alternatively, I can just use the method of cooking, which is my preference for this one. So the first thing first, I'll take these 2 across outside the integral. So I'll put the 2 outside the integral, and then I erase it there. So now I'm just left with what? X squared, right? So this x squared, for me to be able to integrate this, then I need to use method. Since I told you that I'm going to use method of cooking, I'm going to say plus 2 minus 2 here on the numerator. Then I do the splitting from there. So now let me copy down everything. So this is still going to be ln of x squared plus 2 dx is equivalent to x ln of what? Ln of x squared plus 2 minus 2 integral of what? Of x squared plus 2 divided by x squared plus 2 multiplied by dx, and then minus 2 again, the 2. Now I'm splitting. So what did I do? I made x plus 2 to have its own denominator of x plus 2, and again I'm now making minus 2 to have its own denominator of x plus 2, and then as well as this 2 times this integral. So then I splitted them. You make sense, right? Makes some sense. Okay, so the 2 and then another 2 inside the integral. So this negative 2 will multiply that one, so it will multiply this one to form a positive. So allow me to write the positive 1 right there, and then I have got my x squared plus 2. Okay, and then I have my dx. Another thing is that, okay, I can see that already here this is going to be one of the one of the inverses. So I can allow me to take the 2 outside the integral, so it's going to form a 4. So this is going to become 4, you understand? And then inside there, I will be left with 1. And then since I've already identified that this is going to be in the one of the inverses, allow me to write it in the form of x squared, f of x squared. So allow me to rewrite it like this. And then square root of 2 squared. Allow me to rewrite this question like this. Yeah. Now that we're here, this is the same as 1, right? Now we're integrating everything. So let me copy this. So this is going to be ln of x squared plus 2, of course, dx, which is equivalent to x ln of x squared plus 2 minus, so this is the same as 2 integral of 1 dx, right? So when we integrate that, that's just going to be 2x. And then for the other one, we can see that this is tan inverse, because of if we differentiate x, we get 1. So this is just tan inverse. So this is going to be 4 divided by what? A. So it's going to be 4 multiplied by 1 over a. So it's going to be 4 multiplied by square root of 2, because square root of 2 is our a, and then tan inverse of what? Of f of x, which is x divided by a, which is square root of 2, then plus c. Ta-da! we got our final answer there. So that was it for that question. I hope you got it. It was an easy one. Now let's see the last question. Question ya mafello. Question ya ku hetelela about the sister. A question ya ku hetelela le hindla ku sweswi. So yeah, let's quickly do it. Izindleni swin'we question le a ri reng bo bohle. Yo, siyenzeni le question here. Finally. Okay. I've told you about positive odd powers of cosec and secant, right? That we use integration by parts as well to differentiate them. So what we need to do is just to first split them. So we're going to take one of the cosec outside. So it's going to be one of the cosec there multiplied by cosec squared of x dx. And then from there, we then draw our cross. After drawing our cross, the one with the squared, since we know that we know what was differentiated for us to get our cosec squared, then we then write cosec squared here, cosec squared of x here, and then from here we write cosec of x here, cosec of x here. And then from there to here, we differentiate. From here to here, we integrate. So let's differentiate cosec of x. What do we get? When we differentiate cosec of x, we get negative cosec of x. Negative cosec of x multiplied by cot of x, like that. And then when we integrate our cosec squared, we get what? We get negative cot, right? So this is going to be negative cot of x dx. Then a negative cot of x, just like that. And then from here, we're going to copy down our equation. This is going to be cosec cube. So cosec cube of x dx is equivalent to what? Is equivalent to negative cot. So that's equivalent to negative cot of x. Okay, so here the procedure is still the same. We'll multiply the first quadrant, second quadrant multiplied by the third. So it's going to be negative cot multiplied by cosec. So multiplied by cosec of x. Cosec of x minus the integral of, so negative and negative already inside the integral, they're gonna form their own positive there. So I'm gonna end up having cosec of x multiplied by cot squared, right? Cot squared of x dx, just like that. So I know that from square identities, I have one of the identities there that involves cosec and cosec squared, right? So what I'm gonna do here is to change this cot to what? To cosec squared minus 1. So I'm gonna use the square identities to change that one. So let me just recopy everything here. So this is going to be cosec cube. So cosec cube of x dx is going to be equivalent to negative cot of x cosec of x minus what? Minus the integral of cosec of x. So cosec of x multiplied by, so I'm changing cot squared there to cosec squared. So to cosec squared of what? Of x minus 1. I used the square identities. So I can see that now when I multiply this, so now let me remultiply again. So this is going to be cosec cube of x. The x is equivalent to, I copy down again this one, I copy this is going to be cot of x multiplied by cosec of x minus the integral of cosec cube. So cosec cube of x dx. So what did I do here? I multiplied cosec by cosec squared. Now I'm going to multiply again cosec by that one. So again, for that other one, it's gonna be this negative multiplying this other negative, so it's gonna form a positive. So it's going to be plus integral of cosec of x dx, just like that. So from our integration formulas, we know that there is that integral of cosec x, right? Of just having cosec x. So before we integrate it, we know we can already say that cosec cube of x and cosec cube of x, they are the same. So we can take that one across the equal sign. At the end of the day, we'll end up having 2 integral of cosec cube of x dx, which is equivalent to negative cot of x, I'm just copying this, multiplied by cosec of x. So plus, so now I integrate this last part of cosec of x. I know that this is equivalent to ln. So if you have memorized the formulas, then definitely it's going to be easier for you. So this is going to be ln of what? Of cosec of x. So cosec of x minus cot of x minus cot of x, and then you close, and then from there you divide by 2 on both sides. So therefore the integral of cosec cube of x dx, cosec cube of x dx is going to be equals to 1 over 2 multiplied by negative cot of x multiplied by cosec of x plus the natural log of cosec of x minus cot of x, and then you close, then plus c. Ta-da! You have the answer for that one. So that was it, guys, for that question. I hope you got it. That was an easy one as well. So yeah, making it the last question for this video. So I hope you understood everything. Now you can confidently go to your test and chop integration by parts. So that was it from me. Thank you for watching. I'll catch you on the next video. Take care.